Bismillahirrahmanirrahim. I am Ms Rukhsana Yasmeen. I am going to start unit number 4, countdown 8th class. Unit number 4, number systems. Bismillahirrahmanirrahim. Rabbana atina fit dunya hasanatan wa fil akhirati hasanatan wa qina azaban nar. Our Lord, give us in this world that which is good, and in the hereafter that which is good, and save us from the torment of the fire. Today, the talk of the day is education is the passport to the future, for tomorrow belongs to those who prepare for it today. As you know that education is the key to success, hard work is the key to success. Whatever you learn today, that will be your future for tomorrow. If you work hard, you excel, you work for your careers, then definitely you will be successful and you will be at the top of your careers. You look people around us, you can see they do different jobs, they are performing different duties. If I take my example, if I am a teacher, it means that whatever I learn, whatever career I chose for myself, then I prepare it myself for that future. If I want to become a teacher, then definitely I have got this education, I have got these skills, and then I entered in this profession. So similarly, whatever you want to become, whatever career you want to adopt in future, please work for it. And this education is like a passport for your future. As you know that without passport you cannot enter another country. Similarly, without education you cannot enter in any profession. So dear students, work hard and prepare yourself for tomorrow. Now we move towards our lesson. Before starting our new unit about the number systems, we must recall some basic concepts. Now, my question is, how will you define number system? Because from the very beginning, you people are dealing with different numbers. You know about the Roman numbers, you know about the ordinal system of numbers, and so different systems. So my question is, how will you define number system? A number system defines a set of values used to represent quantity. Like we talk about number of students attending the school, number of subjects taken per student. The number system is simply a system to represent or express numbers. Like I say, there are 30 students in my class, then I am expressing that the quantity, that how much students are in my class. Now, why is the number system important? Number system helps us to represent numbers in a small symbol set. Instead of sitting and just counting the things, the number system helps us to represent quantities in just small symbols, 1, 2, 3, 4. Like in computer. Generally, computer uses binary numbers 0 and 1 to keep the calculation simple and to keep the amount of necessary circuitry less, which results in the least amount of space, energy consumption and cost. You can see you can get lot of information from computer, and computer is just using two units, 0 and 1. Okay ji, what is base 1 number system called? You were familiar with binary system numbers, penta-base systems, octals, hexadecimals in computer. Now, I think this is new for you. What is base 1 number system called? Base 1 number system is called the unary numeral system. Unary unit से निकला है. Base 1 number system is called the unary numeral system and is the simplest numeral system to represent natural numbers. Now we move toward our topic, number system. As you can see, it is written that this is the mysterious world of numbers. Numbers are all around us. Now, in earlier days, people used to exchange their things for other things. The requirement for numbers primarily originated from the need to count. They used the numbers 1, 2, 3 that served the people for many years because all they needed to count was just their crops, their animals, their plants. Later on, the numbers such as zero, integers, rational numbers, irrational numbers were introduced. We learn about the whole numbers, the integers, rational numbers, irrational numbers in class 7th and 6th in detail, and we learn that how these numbers originated and how they were introduced. And there is evidence that as early as 30,000 BC, our ancient ancestors were tallying or counting the things. Tallying, that just they put the bars और उसको count कर लेते थे कि कितनी है. That is where the concept of number system began. और उससे फिर हमारा एक number system start हुआ. Now, what is number system in maths? A number system is defined as a system of writing to express numbers. It is the mathematical notation for representing numbers of a given set by using digits or other symbols in a consistent manner. It provides a unique representation of every number and represents the arithmetic and algebraic structure of the figures. It also allows us to operate arithmetic operations like addition, subtraction, multiplication, and division. Because of this number system, we are able to add, subtract, divide, or multiply. And in mathematics, the value of any digit in a number can be determined by the digit. कि वो digit है क्या? 4, 5, 6, whatever is it? Its position in the number and the base of the number system. Now, position in the number system means you must recall that when you have start learning the countings, the how to write the numbers, you have learned the place values of the digits. The place values, units, place, tens place, units, tens, hundreds and thousands, and so on. So, if you know the value of any digit, you must know what the digit is. The position in the numbers mean either it is on the units place, tens place, hundred place, or which place. The base of the number system means that you are working in which system, number system. You are either in decimal system, you are in binary system, you are in penta system, because if you are having a digit 4, then digit 4 has its different value in all the systems. Now, types of number systems. There are various types of number system in mathematics. The four most common number system types are decimal number system, that is base 10, which we most commonly use in our daily life. Then binary number system, base 2, octal number system, and hexadecimal number system. You have already learned about the penta base, yani base 5 system in your computers as well, and we will discuss it in our this chapter also. Now, base of a number system. The base or radix of any number system is determined by the number of digit symbols in the system. For example, binary is a base 2 number system since it uses two symbols. Two symbols mean 0 and 1. And decimal is a base 10 system since it uses 10 symbols. Now, read this line again. The base or radix, base is also known as radix. The base or radix of any number system is determined by number of digit symbols. यानी आप अगर बेस 2 में काम कर रहे हैं तो बेस 2 में बाइनरी में यू यूज़ ओनली 2 digits 0 and 1. That's why the base of binary system is 2. यानी base depends that how many digits we are using in this system. In decimal system has in decimal system we use 10 digits. 10 digits 0 to 9. That's why the base of the decimal system is 10. If we are dealing with the decimal system, when we write the number, then we write 10 under that number. In general, in any number system, a number n can be represented by any one of the following forms. कि आप जनरली किसी भी सिस्टम में काम कर रहे हैं तो n एक जनरल बात है. तो आप जितने भी उसमें काम कर रहे हैं, आप किसी भी सिस्टम में काम कर रहे हैं तो उसकी बेस डिपेंड करेगी कि आपके पास उसमें उसकी बेस क्या है, उसके डिजिट्स पे डिपेंड करती है. इफ़ यू आर वर्किंग इन ऑक्टल सिस्टम, बेस 8, so you use 8 symbols 0 to 7. Do remember this thing that 0 is always included in it. Now some common rules of number systems. All number systems follow the following set of rules. The number of digits symbols available in a number system is equal to the base. If your base is 2, then number of digits in that system will also be 2. Because as we learned in the previous slide that the base or the radix of the number of the digit depends on the number of digits that are used in that system. If there are 2 digits, then definitely base will be 2. If there are 5 digits, it means the base is 5. We are dealing with penta system. The value of the largest digit symbol is 1 less than the base. जैसे अभी हमने बात की कि if we are working in binary system, तो binary system में वैल्यू ऑफ लार्जेस्ट डिजिट सिंबल, बाइनरी सिस्टम में आप सिर्फ 0 और 1 यूज़ कर रहे हैं. नाउ द लार्जेस्ट डिजिट symbol in binary is 1. So now read this. The value of largest digit symbol is 1 less than the base. Binary system has base 2 and binary system has largest digit symbol 1. So this fulfill this rule that the highest value, the largest digit symbol is 1 and 1 is 1 less than the base and base is 2. Take the example of octal system. In octal system, the highest, the largest digit symbol is 7 and base is 8. तो आपको ये बात समझ आई कि जो बेस से जो लार्जेस्ट डिजिट सिंबल होता है वो अपनी बेस से एक नंबर एक लेस होता है. अगर आपकी बेस में 8 लिखा हुआ है तो इसका मतलब है जो आप ऑक्टल सिस्टम में लार्जेस्ट डिजिट यूज़ कर सकते हैं वो सिर्फ 7 है. और मैंने जैसे आपको बताया कि आपने 0 से 7 तक लेके जाना है तो आपके 8 डिजिट्स कंप्लीट हो जाते हैं. Each position multiplies the value of the digit symbol by the base raised to the power of the value equal to the digit symbol position. When you convert in this one system to another, so you multiply every digit by its base, and base is raised to the power of the value equal to your digit symbol position. Digit symbol position वो कहाँ पे है, यूनिट्स में है, टेंस पे है, हंड्रेड्स पे है. वी विल डिस्कस दिस रूल इन नेक्स्ट स्लाइड्स. अ कैरी फ्रॉम वन पोजीशन टू द नेक्स्ट इंक्रीजेज इट्स वेट बेस टाइम. These will be discussed in your addition and subtraction topics. Okay ji. These were the rules which we discussed in previous slides that are followed in almost all the systems. Now have a brief recap of the decimal number system as you have learned all these in your computer class. Decimal number system, base 10 number system. Decimal number system has base 10 because it uses 10 digits from 0 to 9. Now recall the previous slide that number largest digit symbol is 1 less than base. Base is 10 and the largest digit symbol is 9 here. In the decimal number system, the position successive to the left of the decimal point represents units, tens, hundreds, thousands and so on. As you people are familiar with these places because in our daily life, in our mathematics, we follow decimal number system. This system is expressed in decimal numbers. Every position shows a particular power of the base 10. For example, now we will explain this point with the help of an example. For example, the decimal number is 1457, consists of the digit 7 in unit place, 5 in the tens place, 4 in the hundreds position, and 1 in the thousands place or thousand position. Now, you have learned this thing in your class 3, 4, 5, that how we get this number, how this 1457 is formed. You can see that every position shows a particular power of the base 10. 1 into 10 raised to power 3. We learn this thing कि every digit जब आप उसको उसकी base से multiply करते हैं तो base will be multiplied with one number less power. एक power कम लेंगे आप उसके ऊपर. Then 4 into 10 square. 5 into 10 raised to power 1. As you move on, the powers decrease. 7 into 10 raised to power 0. As you know, now I will explain 10 raised to power 0. According to laws of exponent, if any base raised to 0 exponent, it will be equal to 1. So 7 multiplied by 1, you will get 7. And you must remember this thing that when you were in class 3, 4 and 5, units, if a number is at unit place, it will multiply by 1. So basically this is the logic that why the digit at the unit place is always multiplied by 1. Now move to this. 5 is at tens place, 10 raised to power 1. And 4 is at hundreds place, 100 can be written as 10 square. And 1 is at thousands place, 10 cube mean 1000. Now we open the powers and we get it like this. 1 into 1000, 4 into 100, 5 into 10 and 7 into 1. Now you get this expanded form of the numbers when we add together and we get 1457. Now actually this is the sequence, this is the logic that how a number in decimal system is formed. You are familiar with this system. Oh. Now binary number system, base 2 number system. The base 2 number system is also known as binary number system, wherein only two binary digits exist, that is 0 and 1. Specifically, the usual base 2 is a radix of 2. The figures described under this system are known as binary numbers, which are the combination of 0 and 1. For example, if you are having a number 110101 in binary number, we can convert any system into binary number and vice versa. Now vice versa means हमने लिखा है we can convert any system into binary. Decimal system, decimal numbers can be converted into binary, octal numbers can be converted into binary and vice versa mean कि इसका opposite भी exist करेगा. अगर आप डेसिमल को बाइनरी में कन्वर्ट कर सकते हैं तो यू कैन ऑल्सो कन्वर्ट अ बाइनरी नंबर इनटू डेसिमल. If an octal number is converted into binary, then binary number can also be converted into octal. This is called vice versa. For example, if we write 14, this 10 indicates that 14 is written in decimal system. And if we will convert 14 into a binary number system, 14 will be equal to 11102. We will later discuss that how we will convert a decimal number system into binary system. This is just an example that the same number will have different values in different number systems. Now the third type of number system is octal number system. We simply call it base 8 number system. In the octal number system, the base is 8 and it uses numbers from 0 to 7 to represent the numbers. Octal numbers are commonly used in computer applications. Converting an octal number to decimal is the same as decimal conversions. Then hexadecimal number system. Hexadecimal is also known as base 16 number system. In the hexadecimal system, numbers are written or represented with base 16. In the hexa system, the numbers are first represented just like in decimal 0 to 9. Then the numbers are represented using the alphabets from A to F. Okay. Now we move toward the number conversions. Number conversions mean to convert a number from one system to. Numbers can be represented in any of the number system categories like binary, decimal, hexa, etc. Also, any number which is represented in any number system type can be easily converted to. Now, in earlier days, people used to exchange their things for other things. The requirement for numbers primarily originated from the need to count. They used the numbers 1, 2, 3 that served the people for many years because all they needed to count was just their crops, their animals, their plants. Later on, the numbers such as zero, integers, rational numbers, irrational numbers were introduced. We learn about the whole numbers, the integers, rational numbers, irrational numbers in class 7th and 6th in detail, and we learn that how these numbers originated and how they were introduced. And there is evidence that as early as 30,000 BC, our ancient ancestors were tallying or counting the things. Tallying, that just they put the express 20, that is written in decimal system as a binary number. Solution. Now look at the steps. Divide the given decimal number with the base 2. Now देखिए इसमें क्या कहा था, you should divide, this is your quotient and write remainder here. 2 ones are 2, 0, put the dash, write the remainder over here. 2 5s are 10, the quotient is 5, remainder is 0. 2 2s are 4, 2 2s are 4. Keep this thing in your mind, we have to write quotients here. So what is remainder? 1. And 2 1s are 2 and your remainder is 0. Now what we have to do next? Write the binary number by following the arrow direction. You can see this shows that we are moving this and then in this direction. So the 20 in base 10 is equivalent to 10100 in our binary system. Okay, come to the next example. Express 756 in base 10 as a binary number. The same pattern will be followed. Divide the given decimal number with the base 2. Yes, we have divided. Write the binary number by following the arrow directions. Okay, we have written it like this. Now, binary to decimal conversion. अब हमने binary से वापस decimal में आना है, तो multiply each binary number with 2 having the power 0 for last position. Last position means the digit at the unit place starting from the right digit. Increase the power one by one with base as 2 and sum up all the products to get the decimal number. Today the talk of the day is education is the passport to the future, for tomorrow belongs to those who prepare for it today. As you know that education is the key to success, hard work is the key to success. Whatever you learn today, that will be your future for tomorrow. If you work hard, you excel, you work for your careers, then definitely you will be successful and you will be at the top of your careers. You look people around us, you can see they do different jobs, they are performing different duties. If I take my example, if I am a teacher, it means that whatever I learn, whatever career I chose for myself, then I prepare it myself for that future. If I want to become a teacher, then definitely I have got this education, I have got these skills, and then I entered in this profession. So similarly, whatever you want to become, whatever career you want to adopt in future, please work for it. And this education is like a passport for your future. As you know that without passport you cannot enter another country. Similarly, without education you cannot enter. Okay, using expansion method. Now you can see how many digits are there. 1, 2, 3, 4, 5, 6, 7. So you will start from 1 power less. 2 raised to power 6 into 1. Then 2 raised to power 5 into 1. 2 raised to power 4 into 0 plus 2 raised to power 3 into 0 plus 2 square into 1 plus 2 raised to power 1 into 0 and then plus 2 raised to power 0 into 1. Now open these powers. After this step multiply, then open the parenthesis and you will get your answer like this. You have done lot of practice in your computer class last month, so I think it will not be having any problem for you. So this is all in this class that we have learned about the different number systems. And so now this is your turn. You have to solve it yourself, and after the solution you can check your answers. Okay, now it's time to just have a quick recap of the concepts which we learn. That a number system is defined as a system of writing to express the numbers, and it is the mathematical notation for representing numbers of given set by using digits or other symbols in a consistent manner. And the value of any digit in a number can be determined by the digit, by the position in the number and the base of the number. Then we learn that four most common number systems are decimal number system, binary number system, octal number system and hexadecimal number system. And decimal system has base 10 because it uses 10 digits. Then base 2 number system is also known as binary number system. It uses only 2 digits, 0 and 1. And the octal number system, the base is 8 and it uses numbers from 0 to 7. And in the hexadecimal systems, numbers are written or represented with base 16. Then we learn about the conversions, that decimal to binary and binary to decimal conversions. So these were the main points which we discussed today's lesson. Now your homework. Question number 3 of your exercise 4. Use the binary reader to find the base 10 value of the following. Binary readers, they have made in your textbooks, the binary reader is there, or you have to use expansion method basically, and you have to find the base 10 values. Then question number 4, change each base 10 number to a binary number by division method. So this is your homework. I have given almost 10 parts to you in these 2 parts because you have done already done lot of practice in your computer class. So upload your homework at your Google Classroom and your class code is mentioned. So I hope that you have understood well. If you have any problem, please upload your comments in your Google Classroom. Thank you, class.